Yes, in this module we are going to discuss that is 14th question. In the adjacent figure, PQ and RS are two mirrors. So this is mirror. This is also mirror. Two mirrors placed parallel to each other. The distance between two mirrors are always equal, then only if these two are parallel to each other. An incident ray AB strikes the mirror PQ at point B. So this is the point where it is struck, and the reflected ray moves along the path BC. The reflected ray along the moves BC and strike the mirror RS at the point C, and again it's reflected back along CD. So prove that AB is parallel to CD. So what they are given, that one we have to write. So AB is an incident ray, AB is striking mirror PQ. So AB strikes PQ mirror. Then, and along BC, the reflected ray, this is incident ray. You can take it as this is incident. So incident ray, what angle it is there. So let's take here, we're going to divide this as reflected ray and incident ray here, and here also we're going to reflect it this one. So here what it is, that is AB is incidented, this angle let's take A, and reflected ray what it's making angle, that is reflected is let's take B. Then this is the angle incidented. For this normal, we have drawn normal B at B and C. Normal is nothing but that normal is the perpendicular line. So perpendicular line to base, that is the normal here. So we have drawn normal, two normals, and it is incidental. Let's take here, what you can take it here is X, and reflected ray let's take Y. This is the angles it's making. Then BC is the reflected ray for AB, and BC is acting as reflected ray at B and incident ray at C, and CD is reflected ray at C. So this is the given conditions. Then what you can take it here as, so let's write what is that is. So here angle of incident and angle of reflection. So we have drawn angle of incident and angle of reflection. These two are equal. That is angle A will be equal to angle B. So these two angles are according to theory. So what you can say, angle of incident. So write angle of incident is always, according to Snell's law, angle of incident is equal to angle of reflection. So this is angle A will be equal to angle B. Then again one more condition you can write. So here also angle X will be equal to angle Y. This is also angle of reflection will be equal to angle of incident. But angle here, angle B, so let's take angle B and so angle X. These are, what is that? Two alternate interior angles. So angle B and angle S are equal. So angle B and angle X are alternate interior angles. So alternate interior angles. So what is that is, angle B will be equal to angle S. So angle B will be equal to angle S. What you can take here is, so you can draw one thing condition, angle B will be equal to angle X means, then what is that? Angle B will be equal to angle X, that is angle B will be equal to angle Y. So here this AB, angle B will be equal to angle Y. That means, so here what you can take it here as, you can take it as sum of these two angles and these two angles will be always equal. So let's write here A will be equal to B and B will be equal to x. So that means here both are angle B, that is angle x. So let's write a plus b will be equal to x plus y. So these two are equal. That means here this also alternate interior angles. So this is the total angle and this is the total angle. So for this is parallel, for this line is transversal. So alternate interior angles are equal. So based on that, therefore, what you can say here is based on that, AB is parallel to CD. So AB is parallel to CD. So like that we can take. Thanks for watching. Please subscribe.